Okay, this lecture is going to explain what probability is, which is a pretty simple concept. It's the ratio of the desired outcome to all possible outcomes. So if you'd like to know what the probability of X happening is, you're going to take the number of ways that X can occur and divide it by all the possible outcomes, which we call S. Here's a real simple example. A coin is flipped 3 times. What's the probability that we get exactly one tail? Okay, let's look at our sample space. We could get 3 heads. We could get 2 heads and 1 tail. We could get heads, tail, heads. Man, it doesn't like those parentheses, does it? We could get tails, heads, heads. Hello. We could get tails, tails, heads. We could get tails, heads, tails. Good grief. Okay. Almost done. We could get heads, tails, tails. And finally, all 3 tails. So that's our total sample space. Notice that there's 1, 2, 3, 4, 5, 6, 7, 8 possibilities. And you recall from our counting principles lesson that if you have 2 possible outcomes and you do 3 trials, then the total number of outcomes is 2 to the third. If we did 4 trials, then it would be 2 to the fourth, and so on. Okay, so let's take a look and see how many times exactly one tail rather, turns up. There's 1, 2, 3. So the probability of one tail is equal to 3 divided by our sample space, which is 8. Okay, the next concept you have to know about probabilities is that an event and its complement always add up to 1. In other words, the probability of A occurring plus the probability of not A occurring always adds up to 1. And here's a good example. What's the probability that 2 people in a group of 8 have the same birthday? If we let the probability of B be 2 people have the same birthday. Hello. Then the probability of not B is that no 2 people have the same birthday. Now, why do I want to do that? Because it's much easier for this example to calculate the probability of not B than the probability of B. So what we'll do is we'll say, well, the probability of B, which is what we want, is going to be 1 minus the probability of not B, which is easy to calculate. So that's going to equal 1 minus. Okay, so if nobody can have the same birthday, that means the first person has 365 days to choose from. That leaves 364 for the second person to choose from, and 363 for the third person to choose from. on down to 358 for the 8th person to choose from. So we're going to multiply all these out. Divided by the sample space, which is 365 to the 8th power. That's going to equal 1 minus 0.92566, which is equal to 0.074, which is about a 7.4% chance that two people in a group of 8 have the same birthday. Okay, next, if events are mutually exclusive, which means they have no effect on each other, then their probabilities can be added. In other words, P of A or B happening is equal to the probability of A happening plus the probability of B happening. Here's an example. A fair coin is tossed 6 times. What's the probability of obtaining between 4 and 6 heads inclusive? Alright, because each toss has no effect on the next toss, these are mutually exclusive events. The sample space S is 2, because we have 2 outcomes, heads or tails, to the 6, because we're doing 6 trials, and that gives us 64. So that's the number of the sample space. We need to calculate the probabilities of attaining a 4, a 5, and 6 heads and add them together. So the probability of getting 4 or a 5 or a 6 is equal to the number of ways we can get 6 choose 4 divided by 2 to the 6th plus 6 choose 5 divided by 2 to the 6th plus 6 choose 6 divided by 2 to the 6th, which is equal to 15 over 64 plus 6 over 64 plus 1 over 64, and that works out to 22 over 64. So almost a third of the time you're going to get between 4 and 6 heads inclusively. And that's pretty much it, what you need to know for probability. Good luck on your worksheet. You're welcome to work with a partner or 2 or 3 at a time, and this is due Wednesday.